Hello and welcome back. In general, any machine learning problem can fall under one of three types of learning: supervised learning, unsupervised learning, and reinforcement learning. So let me introduce you to these three types. First, supervised learning, which is the most common in machine learning problems, unlikely the first to be introduced in any machine learning course. In these types of problems, you are given a dataset and you are also given the corresponding output. For instance, you get an email dataset, and for each email you know whether it is spam or not. And the goal is to build a model from this data so that if a new emails arrive to your inbox, the model can determine correctly if it should go to your primary folder or it should go to your spam folder. So the model is trying to answer a yes/no question. Is this email a spam or not a spam? So this is basically the question. So in summary, you have the data, which is the examples, and you have the corresponding output for each of these examples. Second type of learning is unsupervised learning. It is similar to supervised learning, however, the input data does not come with the corresponding output. So we approach the problem with a little or no idea what our output is or how it should look like. So we build a model or solution based on the relationship among the variables in the data. A simple example will be Google News. It takes a collection of many different news and it finds a way to automatically group this news into groups that are somehow similar or related by different variables. It goes through different articles and it determines this belongs to the political section, this belongs to the entertainment section, this belongs to the sports section. There is no one person actually going through this manually and determine that this goes to this category or this goes to other. It happened automatically through machine learning. Third type of learning is reinforcement learning, which is the area of machine learning concerned with how computers should take an action in an environment to maximize a reward and automatically improve its performance through experience. Let's give an example to clarify what I just said. So we have a computer, a camera within a self-driving car, and it interacts with the road, people, other cars to learn how to navigate a city. The environment here is the city, the people, the cars. The reward is making it to the final destination safely and probably using the shortest way possible. Let's look at this diagram. It shows us three types of learning and the sub-areas within each type. For instance, supervised learning problems are categorized into regression and classification. In regression, we are trying to predict result within a continuous output. And in classification, we are trying to predict result in a discrete output. Let's say we are given a data about patients and heart disease. And we are trying to give a score that represents the probability that a patient will have a heart disease in the next 5 or 10 years. The score as a function is a continuous output, so we will call this regression. However, if you are trying to answer whether a patient will have a heart disease in the next 10 years, so it's a yes/no answer, two discrete categories, we call this classification. So as you can see, some of the applications for classifications are image classifications, fraud detections, and others. Similarly, unsupervised learning has several sub-areas like clustering, dimensionality reduction, and you can also see some other applications for reinforcement learning as well in this chart. We will talk about each one of these in the next course and some of the most used methods and algorithms under each learning type. But for now, I hope you have a general idea about them and how they are different from each other. For the remaining part of this course, we will go through an example and we will see how everything we have talked about so far come together and applied.